Hello, welcome to the Code Physics channel. Today we want to look at a topic known as electronics, and particularly a part known as the p-n junction. So sit back, relax and enjoy. This is a p-type semiconductor in which the majority charge carriers are holes. And this is an n-type semiconductor in which the majority charge carriers are electrons. When these two are joined together, the region where the two are meeting is what we call a p-n junction. How does a p-n junction work? Okay, what's going to happen here is that electrons on this side here are going to cross over the p-n junction and they come onto the side of the p-type region near the p-n junction. Now they'll find here holes and they will fill these holes. Okay, and when they fill holes this side here around this region here, what's going to happen is that negative ions are going to be created around this region here. Likewise, the holes which are this side here, they are going to come and pass over, or they are going to diffuse through the p-n junction onto the n-type side. And when they come onto the n-side type, they are going to attract electrons. So they are going to be filled by electrons. Now, this is going to lead to a creation of positive ions on this side here. So you find that here we are going to be having the positive ion on the side of the n-type side and negative ions on the side of the p-type side. Now these negative and positive ions are going to lead to a creation of a potential difference in this region here, and this potential difference will stop further movement of electrons from the n-type side to the p-type side, and also stop further movement of holes from the p-type side onto the n-type side. Now the PD that is created at the p-n junction that stops further movement of electrons and holes from one side to another is what we call the junction voltage, or it can be called the barrier potential. Also, the region in the middle near the p-n junction does not have charge carriers. In other words, it does not have electrons and it does not have holes. So this region, because it does not have these charge carriers, is known as the depletion region or the depletion layer. Biasing a p-n junction. In electronics, biasing means applying a voltage or a current to a device. So in this case, when we apply a voltage or a current to a p-n junction, then we are saying that we are biasing the p-n junction. There are two ways of biasing a p-n junction. Number one, we have the forward bias, and number two, we have what we call the reverse bias. Forward bias. In forward bias, what is going to happen is that the positive terminal of the battery is connected to the p-type side, and the negative terminal of the battery is connected to the n-type side of the p-n junction. Now, when these connections are made, we find that the positive terminal of the battery is going to repel the holes that are found in the p-type side. It repels because the holes are considered to have a positive charge. Okay, and our terminal here is also positive. So positive and positive is going to create a repulsive force. Also, the negative terminal of the battery is connected to the n-type side. This implies that there is going to be a repulsive force by the negative terminal onto the electrons that are found in the n-type side of the p-n junction. Now, when this repulsion happens, that is the holes being repelled and the electrons being repelled, they are going to be pushed towards the p-n junction. Okay, and as they are pushed towards the p-n junction, this is going to lead to the reduction in width of the depletion layer or the depletion region. And if the depletion region is reduced, that would mean that electrons will be able to cross over from the n-type side onto the p-type side. Likewise, holes are going to be able to cross over from the p-type side onto the n-type side. And if this scenario happens, it means that we shall have an electric current that is flowing. Okay, electric current is going to flow because the depletion region is going to narrow, it is going to become small, and so electrons are going to move. As they move, they complete the circuit, and therefore we have an electric current that is flowing. In the reverse bias, the connections to the external parts of the p-n junctions are going to be reversed. That is, the negative terminal of the battery is connected to the p-type side, and the positive terminal of the battery is connected to the n-type side of the p-n junction. Now, if this connection is done, this is negative, okay, negative terminal of the battery, and this is positive. Of course, if you have a positive and a negative, there's going to be an attraction. Okay, so this implies that the negative terminal is going to pull the holes away from the p-n junction. Likewise, the positive terminal is going to pull the electrons away from the p-n junction. Now, if this happens, this is going to lead to an increase in the depletion layer or the depletion region. And if the depletion region is increased, that means that it will be impossible for electrons to cross over from the n-type side onto the p-type side. Likewise, holes to cross over from the p-type side onto the n-type side. In this case, we find that when we have a reverse bias, it is not going to be possible, or it is going to be very hard for electrons and holes to move from one side onto the other side. A p-n junction acts in such a way that it allows current to flow in one direction, okay, and it does not allow current to flow, or it allows very little to flow in the opposite direction. A device which acts like a p-n junction is known as a diode. A diode is an electrical device that allows current to flow in one direction with ease than with the other direction. In other words, when a diode is connected in forward bias, it is going to allow current to flow. But if it is connected in reverse bias, it is going to not allow current to flow, or if it allows, it's going to allow very, very little current to pass through, and it's behaving like a p-n junction. Now, the side of the p-type of a diode is known as the anode, and the side of the n-type of a diode is what is known as a cathode. A diode is represented by the symbol shown below. So this is the symbol that represents a diode, in which case this side here is the anode and this side here is the cathode.